Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. An insurance agent will receive a bonus if his loss ratio is less than 70%. You are given that 1. His loss ratio is calculated as incurred losses divided by earned premium on his block of business. 2. The agent will receive a percentage of earned premium equal to 1/3 of the difference between 70% and his loss ratio. 3. The agent receives no bonus if his loss ratio is greater than 70%. 4. His earned premium is $500,000. 5. His incurred losses are distributed according to the Pareto distribution with a cumulative distribution function f of x equal to 1 minus 600,000 divided by x plus 600,000, the whole quantity to the power 3, so cubed, for x greater than 0. Calculate the expected value of his bonus. And here's the solution. Let us write x for the incurred loss and w for the value of the bonus. Note that the smallest possible value of w is 0, and the largest possible value of it is 1/3 times 0.7 times 500,000, so it's 350,000 divided by 3. Then for w greater than 0, we have the probability that w is greater than w is equal to the probability that 1/3 times 0.7 minus x over 500,000 times 500,000 is greater than w, which is the same as the probability that x is less than 350,000 minus 3w. And according to the formula given for the cumulative distribution function, that's equal to 1 minus 600,000 over 350,000 minus 3w plus 600,000, so this becomes 1 minus 600,000 over 950,000 minus 3w. The whole quantity is cubed. Also in the previous formula it was cubed. So we also have the probability that w is equal to 0 is the probability that x over 500,000 is more than 0.7, which is positive, so that the distribution of w has a point mass at 0. And we will, of course, use the Darth Vader rule to calculate the expected value. And the point mass has no effect on the integral of the survival function from 0 to plus infinity. And in fact, we don't need to go all the way to plus infinity. We just need to calculate the integral of the survival function to the greatest possible value of the random variable w, which is 350,000 over 3. So that the expected value of w is the integral from 0 to 350,000 divided by 3 of the survival function of w, which is, as we just calculated, 1 minus 600,000 over 950,000 minus 3w to the power 3. Okay, so we integrate this function, and the integral is equal to 600,000 cubed. That's just the coefficient taken out from this ratio there, which is cubed, over 6, which corresponds to the appropriate power of w in the calculation to get to the function whose derivative is the integrand, times 950,000 minus 3w to the negative 2. So you can just check that that's the function whose derivative is the integrand. And we evaluate it from w equal to 0 to w equal to 350,000 over 3, with, of course, this 350,000 over 3 which is at front there. That's the value of this whole integral, but when it's calculated for 1. So this 1 minus this fraction cubed is really split into two functions that we are integrating, and the integral of 1 is simply 350,000 over 3 that you see there. Okay, so this becomes 350,000 over 3 times, minus, the difference of the values of this function that we're calculating at w equal to 0 and w equal to 350,000 over 3, and that's 600,000 cubed over 6 times 600,000 squared minus 600,000 cubed over 6 times 950,000 squared. And we calculate all that and we get approximately 56,555.86, which is answer E. Please remember this is copyrighted material. The problem originally comes from the Society of Actuaries and belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.